Yeah, this is a squeeze theorem problem. So I'm not going to tell you on a test that you have to use squeeze. If you make a pretty graph of the situation, I won't give you any credit. So every time we witness one of these, we have to see that there is no way for us ever to get that argument, 1 over 7x, to be anything we can understand. So when we have a trig function, we stick with our knowledge of range. All right? And our knowledge of range is going to tell us to do this, that we can write this. Does everybody agree? And that is a powerful statement because you've got to remember on squeeze theorem, you're trying to show two functions that you know on either side of the function that you have. And now, by multiplying everything by x squared in blue, we have now sandwiched our function in between two known functions. This is the key. The red and blue are the key steps here to squeeze theorem. We have made this sandwich. And if it helps you graphically to think about it, and I'm not sure what the sandwich one looks like, but I know negative x squared looks like this. And I know positive x squared looks like this. And I have an idea that this middle function looks something like that, where at 0 it is absolutely positively undefined. This function does not exist at 0. Its limit does, right? This is a removable discontinuity, or just a, you know what I mean? It's just an open circle in the graph. So where do we got to go? Well, now we know from squeeze theorem, if you can prove it, first things first, before you say thus, if you can prove the outside two limits are the same, and everybody, this is by direct substitution, right? Because these are polynomials, negative x squared and x squared, right? If I want a limit of a polynomial, just stick it in and get me a value, right? Direct substitution. Now we go thus. And the big deal, thus by squeeze theorem or sandwich theorem. I think it's almost always squeeze theorem now. Thus by squeeze theorem, since boy, something's scaring me up at Albany. Since we have sandwiched in, since we've sandwiched our function in between, and the limit of the outside two are equal, then the limit as x approaches 0 for our middle function has to be the same. Boom. All right. We talked a little bit about IBT, having a list of ideas. Big idea here, everyone. Again, the big idea here is the idea that you can pin it and pin it so that you can think of this graph. Does that make sense, everybody? You can make the functions in between, all right? And then, I can't stress this enough, you have to show the limits of the outside two are the same. Then you can make the thus statement. Thus statement is that the one in between then has to be the same. We have squeezed our unknown function between two known functions. All right? That is the big deal.